Hi there. In this video I'm going to cover plan reading basics, and I want to stress that I'm only going to cover the basics of plan reading because ultimately this is very much a materials and methods type topic, how materials are assembled and then represented on plans and sections, elevations, and also in 3D models for that matter. Very much depends on the various materials and building systems, and other courses are covering that more. But we're going to start off with the basics so that you find your way around a plan set and you know what you're looking at. And then this will be expanded on later. Alrighty, so plan reading. What we're looking at here are basically 2D sheet sets. This is something you'll find on every construction site. It's typically the basis for the legal agreement. And so that's why even though we're now creating entire buildings in 3D, the 2D sheet sets are still very important, but nevertheless, even they are very often consumed and looked at in a digital format. So very typically you're going to be looking at those as PDFs and maybe even as 3D models. And some of those are interactive, some of those are just very basic PDFs, and then sometimes you're going to be looking at printed out paper sheets. There's a variety of sizes that could be used for all of those, and those you can look up. They range from 12 by 18, which is the architectural B size, all the way up to 36 by 48, which is the E size. They all are labeled, and sometimes a larger sheet set gets printed smaller, which then obviously is not to scale, but you can at least read things out of it and use it as a reference and so on and so forth. So there's all of that, and these can be very large collections of sheets. Contemporary building can have hundreds of sheets, especially if it's very complicated. If you're building a hospital or something like this, those are very extensive sheet sets. Okay, so now what are we looking at? Let's start by looking at the plan set or the sheet set. And in this particular video, I'm going to be looking at it with the example of the Olver Design Building, which is of course where we're housed. And you're going to see some of those sheets in these videos and on these slides. Okay, so a plan set at the beginning always has this number one sheet, which is the cover sheet, the title sheet. And on a title sheet, you have a little bit about the project. There's usually a picture. There might be a site, as you can see there, the address, etc., etc. There's also, and I just covered it up a little bit right here, the status of the plan, because there are different plans issued at different or plan sets issued at different phases during the construction process, and so then you could compare them based on what status this particular plan is. And what I'm looking at here is the as-built set plans for our building. Then there's usually a legend, abbreviations, all of those kind of things, just to make it clear what you're looking at inside the plan set. And then consultants are typically mentioned and labeled and signed as well on the title page. And that's a typical title page for a larger project. For a smaller project, what comes next is often also included on the title page, because for a residential project, for example, you don't have as many sheets. But number two, page number 2 in this case, is a sheet list. So next you will have an index for the whole document. You'll find every single sheet listed there with a proper sheet number, and we'll cover that in a second, and the corresponding title. All right, and like I said, sometimes both of those are on one sheet if it's a smaller project, and sometimes the sheet list is even longer than what you're looking at here. But this helps you get into the plan set. And next, of course, you're going to be looking at sheets, and you're going to be looking at lots and lots of sheets of the various disciplines. I pulled out an architectural sheet here, and you can see that it's an architectural sheet by its number. So every sheet has a number, The number typically consists of a letter and a number. The letter tells you something about the discipline. So there's A for architecture, civil for C for civil, S structural. Then we've got L for landscape, HVAC, H, E electrical. There's a fairly long list of those, and they basically organize the sheet set. And often they're supplied by consultants, and they may look slightly different, but they're usually assembled in that larger sheet set. Okay, so next to that letter is a number, and it's somewhat consecutive. Sometimes it's 100, 200, 300 or something like this. In this case here you see 2.01, so there's some kind of a sub-numbering scheme there too. It's often or it can be different, and it is very much up to the designer to come up with a system and stick to it for that matter. Then on a sheet we have a view, at least a single view, as in this case, which is a floor plan, or we have multiple views. But before we get to that one, let's start from the outside. On the outside we have the title block. And the title block can have different designs again. Typically also has a border around the entire sheet, which you see up here, of course, and then contains a ton of information. So this is where you find the number, as I just showed you. You'll find the title of this particular sheet, what it is, what's on it, floor plan, for example. You'll find something about the project and some details about that, typically who the client is, etc., all of those kind of things. Then there's also, consultants mentioned on there. Sometimes that gets signed off, obviously, and so on and so forth. So there's a fair amount of information right on this title block. And typically, as a last one over here, you also have revisions, because everything gets revised at some point, most everything at least. And whenever these sheets get revised, a revision gets added to these sheets, and then, of course, at some point the entire sheet gets reissued. Nevertheless, this is where you find those, and where you find those comments about revisions. The title block typically, or basically this border, as you can see up here, typically has a slight border around the sheet, typically about a ½ inch border. But again, this is very much dependent upon the particular design of this document set. Okay, so that's the outer part. Now you know what you're looking at. Now we're going to go into the sheet, and then, like I said earlier, there's a view. And in this case, it's a floor plan. Could be an elevation, could be all kinds of things, and I'll show you a few of those in a second. Some sheets have many, many details in a grid, and those are then typically called out from these floor plans, and I'll show you in a second how that looks like. But that is the view that's on this sheet. Every view has a title, and that is typically a number, a title, and a scale. And only when something's not to scale might the scale be omitted, or it says NTS for not to scale. But there's always a title and a number for the view, because you will want to reference it from other sheets and other places. One last thing that you see here is this bit of text down here, and that is fairly common to have annotations on sheets. Some have it, some don't. Annotations get added when, of course, the visual presentation on the sheet, the data that's in the drawing itself, isn't enough, and you need to explain something a little bit more in depth, and then an annotation gets added. We all have to keep in mind, of course, that there's always a spec book that goes along with this that has a lot of specs spelled out in much greater detail. And so between these three things, between the visual representation of your plan, the annotations that are on the sheets, the tables and schedules, and we'll look at those in a second. And the spec book, that's where you find all your information that you need. And of course, if you don't find it anywhere there, then you'll start issuing RFIs. Okay, so that's what's on a sheet. And like I said, particularly here, we're looking at a floor plan. So now, before we look at specific plans, let's look at these views a little bit more generic, and there's a variety of different views that are in these plan sets, and you just need to understand what you're looking at. So first one is my plan, which is a horizontal cut through the building, and is typically done 4 feet up from a particular level. So if my level here is there on the ground, then 4 feet up, that's where my first floor plan view is located. Then whatever that cuts through, walls and permanently installed items and so on and so forth, that will be represented on a floor plan. And anything that you can look at when you're looking down at the floor, so very often even floor patterns will be represented there, although sometimes they're omitted because it makes it just too busy to look at. There are sometimes things, above a floor cut plane and or floor plan cut plane, and those need to be included somewhere. This could be a drop ceiling detail or something like this, and then that would be included in the floor plan with a dashed line, and then you can at least find out where it is, and then you can maybe look at a section or an interior elevation to get some more information on that. Okay, so that's your floor plan. We just talked about ceilings, and let's draw in a ceiling here. That needs to be represented too. You need to somehow make clear where the lights go and the HVAC outlets, etc. And that is done with a reflected ceiling plan, an RCP. Reflected ceiling plan basically means we're looking up, but it's done in a way that we're kind of taking the ceiling and we're reflecting it off the floor. And I'll show you in a second what that means. It comes down to the fact that the floor plan, the outline isn't flipped. It's not like you're looking up at the building, you're looking down at the building, but what you're seeing is the ceiling. So I'll show you that in a second. And one way to understand that is basically thinking of it as this cut section right there. Okay, so that's the horizontal sections. Now let's take a look at the vertical sections. If you cut straight through your building, then it's a building section, and it can be done through the entire building. It can be done in any direction. It can be done just through a smaller portion of your building. Maybe you just want to show a wall section, a vertical part of stacked walls, etc. So that is a section, and a section always looks in a particular direction. And I'll show you again in a second how that's indicated on plans, but you can see it already here. The symbol basically tells you which way you're looking. Now, if you took that section and you pulled it out and looked at the entire building from the outside, then of course it's a building elevation, and that again looks one particular direction, typically towards the building if you've done everything right. And that of course shows you things like facade details and so on and so forth. There are also interior elevations, which I haven't illustrated here, and you can kind of imagine how that looks like. Interior elevations are typically bounded by the ceiling and the floor, so it's not a section, but a portion of a section actually becomes an interior elevation, obviously. Okay, so that's in theory how it looks like. Let's take a look at how this actually looks like in our design building plan set. Okay, so this first one here is a floor plan. Again, we're cutting through the entire building, at a 4 feet height of the finished floor. And then, of course, everything that's there is shown: walls, doors, ramps, etc. All kinds of things. So that's the floor plan. And then when you look at a space, our classroom here on the left, then you'll see what you're looking at. In this case, it's not a furniture plan, so you don't see the furniture. The reflected ceiling plan, which is number 2 here, as you can see, has the same orientation as the floor plan, because again, we're looking down in terms of orientation, but we're representing the ceiling. So you can imagine it as having the floor basically be a big mirror, and then by looking down, you're seeing what's above you. That of course makes it easier to understand the plan and to know where everything is without having to flip the whole thing. So for our classroom, again, here's my detail. You'll see all the lights, you'll see HVAC elements, etc., etc. So that's what's represented in a reflected ceiling plan. Next is a section. Section basically means I'm going to cut through my building and I'm going to look a particular way. And then number 3 here is, of course, that section. Whatever you're cutting through is represented, and very often pochade, which basically means that it's just turned black. But in this case it isn't. And then of course what you're looking at, like the stairs here and so on, that is represented, as a section view or an elevation view of sorts. And so then this gives you a view through the building at a particular location, and again in a particular direction, obviously, because you're looking only one way. Then if you looked from the outside, right here, at the building, and that of course would not be a section, but that is your building elevation, which is number 4, and that's where you see facade elements, windows, etc., etc. Okay, so those are kind of the basic views that you have, and then even details follow those views more or less. A detail could be in plan view, a detail could be in elevation view, it could be a section through a wall, etc., etc. So you'll see more of these come up in a little bit. Okay, so let's take a look at basic symbols. And again, this particular one comes from our design building plan set, but they all follow pretty much the same rules, although individual designers may have different ways to illustrate things. Okay, so let's start top left. We got a dimension. This is a dimension string or a chained dimension, and that's very common where you're following one dimension with another. And then these little tick marks, as you can see here, tell you where a dimension ends. So then in addition to these 2 individual dimensions, very often you have an overall dimension right there. And then that calls out, of course, what that overall dimension is. And that way you don't have to do the math to sum those up. And sometimes you still have to kind of chase down some dimensions because the particular one you're looking for is missing, but then 2 other ones will tell you what it is, that kind of stuff. These strings sometimes, or these tick marks, are sometimes done as dots. There's all kinds of ways to doing this. You can do arrows, obviously, but the diagonal dash is fairly common for architectural plans. Okay, second one is our detail reference, sometimes called a callout. And what you do here is you put this dashed bit over a particular detail, a wall or something, and you want to call it out somewhere else as a detail, for example. Then the numbers that you're looking at here represent 2 things. The top is the detail number, and the bottom is the sheet on which you will find that detail. So it's a really nice reference, and you'll see this logic shown with sections on the right again. The top is always the number and the bottom is the sheet. And like I said earlier, particular detail sheets can have lots and lots of individual details. So that's your callout. Next we have the column grid. Right here it's a circle with a letter or a number, and then this dash, long short dash line. Column grids obviously are, making this a little too close, are in both directions, and then your second direction typically has numbers. And then if you want to reference a particular column, then you'll reference it as A1 or a B3 or whatever. That gives you then a good way to reference those. So the column grid is in both directions, both dimensions, does not need to be evenly spaced, and very often isn't. So you'll find those in plans, of course. Next we have the view name, and like I said earlier, the view name is consists of a name that describes what you're looking at, of course, a scale, and a number. And the number is always consecutive on a particular plan, so it starts with 1 obviously and then goes up, and if you have lots of views on a plan, this can go up quite a ways. This particular tag sometimes looks a little different, often has a circle around the number and a line, but it's done in all kinds of ways, and again depends very much on the particular designer how they want to show it. Ceiling heights could be shown by a ceiling tag, as you see here. Room labels are really common. You'll find them in all kinds of spaces. It doesn't necessarily need to call out a room. This could be calling out a portion of a room, especially if it's an open space that's subdivided into things, cafe, atrium, all of those kind of things. And so then that's fairly typical on floor plans, where you then obviously have the actual room name. Then everything is numbered, every space is numbered, so that numbering below represents that, and then sometimes you also have square footage underneath. Callouts, right here, are basically just pieces of text with a leader line. It's leader text sometimes, and it just basically means that whatever you're looking at, whatever you're pointing at here, that's called out, that's spelled out in the text here. An elevation is shown, as you can see on the bottom here, and that horizontal line tells you exactly where that elevation is. Those can be absolute elevations, above sea level, or it could be relative elevations relative to a base point or base plenum in your project. Now let's jump to the right side. There's a reference point that is employed. Next we have a section, and I mentioned sections earlier, and this is basically how the tag will look like. The little feather bit there on the bottom is actually, or the flag is typically on the opposite side of the building if it's a building section, so this can be a fairly long line, but the two parts are the same. The head shows you where we're looking. In this case we're looking up, and it also tells you where you find that respective section. So this would be a section 1 on sheet A101, and you can easily find it. If this is just a portion of a building, then this end part will indicate how far your section extends, basically. Interior elevations are typically called out like this. You have a circle with, again, the sheet name or sheet number in it, and then arrows that point in particular directions, and this then tells you that the interior elevation number 1 that looks to the right is on that sheet, and so on and so forth. Typically corresponding interior elevations will be on the same sheet. Outside building elevations, again, look fairly similar. Same logic as before. In Revit, by default, they're actually a rectangular or square, but in principle, it's all the same. Next, we have your center line. If you're calling out a center line for something, that's the CL. Then in this particular set, we're using this tag for partitions, and now the next three, actually partitions, doors, and windows, those are tags where those items are numbered, and then you would find them on in tables, basically where your various schedules are, as in a door schedule, a window schedule, etc. Although there's also a room schedule, which I didn't mention earlier. Door tags are numbered typically by room. So you'll find room 100, door A, door B, door C. Windows are typically numbered by type. So if you have a lot of the same window type in your project, then of course they'll all have the same number. Okay, so next let's take a look at measurements and how they're represented in a plan set. Again, we're using the design building as an example. So on the floor plan example that you see on the left here, you'll see that the chained dimension that I talked about earlier. So typically that is given for windows, as in this case, or for interior dimensions, as in that case. And that usually allows you to figure out even in between dimensions, through subtracting, adding, etc. Obviously, you can't dimension everything in a project, and if you need to measure something in addition to these, you will most probably use an architecture ruler if it's a printed sheet, or PDF readers, and some software can easily help you measure things. Bluebeam, Acrobat, all of those let you then calibrate a plan using a given dimension, and then you measure everything else out as needed. So it's very easy to do and very, very fast. So how do you dimension? This very much depends on convention, materials, etc., etc. So for interior, you very often do surface type dimensions, interior surface to interior surface. Although interior partition walls are typically dimensioned at the center line, although in this project they're not. They're actually dimensioned at the surface line. But this is very much a convention that you need to figure out project by project. Exteriors and windows, as you can see up here, can be dimensioned on their center line or on their rough opening dimensions. Traditionally, masonry window locations are dimensioned on their rough opening, because you need to figure out full brick lengths or block lengths, and then light frame, and in this case actually our exterior wall is steel studs. It makes more sense to lay these windows out on the center line, but again, this is very much project dependent, and it depends on what you need, what you would have there. In addition to this chain that you would see up here on top, you may actually have a summary dimension, an overall length type measurement as well. But again, if it's not there, you'll have to do the math to get there. There are a few other things that you see here on the left. You'll see the room tag, as I mentioned earlier, with the number and square footage in this case. You also see that in this particular space, we've got 3 subspaces. So this dashed line that you're looking at here delineates the subspaces even in a single room. And then, of course, if you want the overall square footage, you have to add all 3 together. You also see the interior elevation tag. So if you wanted to look at the elevation for this right wall here, you look at detail number 4 on sheet A522. And the reference is right there. Likewise, for partition walls, there's a tag attached to every single partition wall that references a particular wall detail. And if you need to build that wall, of course, that S4 type partition wall is what you need to build at this particular point. Door tags, I mentioned earlier, are numbered by room and then number of door. So in this case, this is room 160, and so then it's first door in room 160 is, of course, 160A. So that's pretty much all that's in this left view here. The right view shows you a vertical elevation view of the building, of the exterior building, which is where you see a few other things. You see, for example, our column grids. So A delineates one of the column grids, structural grids, of course. And as you can see here, sometimes you have subgrids, and sometimes there's this particular numbering scheme that you just have to make sense of to understand those subgrids. But this shows you a column grid. Then on the right you see a level tag, and this particular one is for the upper roof. Then you see fourth floor and so on and so forth. And as you can see, these levels are tagged with absolute heights. And again, this depends on your project, what your needs are. You see another chain of dimensions here, and then of course this overall dimension, and then the facade dimensions. So very often you have multiple dimension chains and overall dimensions side by side, and of course you don't want to clutter up a plan too much, but you also want to provide enough information to understand what you need to build if you're the plan author, and of course as a plan reader you want to get as much information as possible. One quick word on these elevation tags, or these level tags. This is always finished floor height. So depending on what kind of flooring you have, that level is your finished floor height and will remain like that. For example, if you are creating a building in design software and you change the floor type, then of course it doesn't change upward. Usually it changes downward. Okay, so that's the level tags. We've got the dimensions called out. Last thing you see here are also the window tags, and you can see, of course, because all of these windows have different dimensions, most of them actually do. Those with different dimensions are numbered differently, but as you can see here, these two windows have the same dimensions, so they get the same number. Those two windows get the same number, and so on and so forth. So that is window tags. Okay, next let's take a look at details. Like I said earlier, you'll see a lot of details in these plans. You'll see callouts in floor plans and elevations that reference these details. So that's usually how you can find them. And then there are sheets of basically lots of details side by side in a grid format typically. On the left you'll see a vertical section. There's a floor plate, there's a wall, and you see the various things that you can see in the detail. So typically there's your level again, the floor level is called out so that you have a reference what you're looking at. There might be other levels that are being called out. Then you're cutting through material. So this is now where you're seeing boundaries of the various objects, material layers, and so on. And the materials are represented as hatch patterns, and we'll cover that in a second. So then you'll see all of that, and you of course also have a bunch of dimensions. So depending on what's needed here, there should be enough dimensions presented for you to understand what goes where. And typically you reference those of something that's fairly common, and you kind of build inside to out. So you'll see here my column grid is shown, and I'm actually dimensioning the wall of the column grid, which allows you then of course to build out the details, because typically, the structural column will be up first, and then you'll fill in walls much later. You'll also see a lot of annotation text. There's going to be some specifications there. There's going to be, at least an explanation of what you're looking at presented, and that then completes a detail like this. At the base of the detail, like I said earlier, you always have a description of the view, which is the number, the description, and the scale, and every single one will be called out like this. There's one thing that's not shown here. Typically, whenever you break material like this, you could show it as shown here, or you may encounter a break line, which is basically this kind of squiggly line like that, which shows you that you're breaking material, especially if you are showing something in one detail where you're kind of removing the middle. That's where you'll find these break lines. So if you see those, they basically just tell you there's more to the right. Then on the right, strangely also number 7 is a furniture or casework detail with similar attributes. We've got a level here. We know where the floor is. We know what goes into this particular piece. Things are called out, and then we've got dimensions. Sometimes you have what you see up here, which is basically an equal spacing, and you got to figure out where the middle is. And of course, this explains more the design intent than actual dimensions, which is of course useful. You saw in a second ago that material patterns are important. Material patterns appear when you cut through materials, either in a vertical or a horizontal cut, and typically, of course, mostly visible in these details, because once the scale gets too coarse, then of course you can't see anything, and this wouldn't be shown. But these are fairly standard material patterns and hatchings, as it's often called. Let me just pick out a few. So brick would be the diagonal line, and concrete is stipple pattern, although it usually has these triangles in there. They're a little too small to see right now. Concrete blocks are two-way diagonals, and that's how it looks slightly different from brick. Rigid insulation is similar to the concrete masonry unit, just horizontal and verticals, and then everything else is also shown there. So steel is this double line kind of thing. Some of these are appearance patterns. So if you have a brick wall in an elevation, of course you're trying to represent the pattern that the brick makes, and so on. On the right, you'll see a few other things. The bottom detail is an interior wall detail, where you see this kind of squiggly line thing in the middle, which is bat insulation. Oops. So whenever you insert bat insulation, that's how it looks like. And this particular wall is a steel frame wall, so there is actually a steel track represented there at the bottom, but it's so thin that you can't see it, but it's called out right there. If you have a light wood or a dimensional wood element somewhere in there, so for example like a 2x4 or anything larger than that, then it's represented, as you can see up here, as actual size and then blocked out with this cross. Glulam is represented differently with the actual layers, but any kind of dimensional wood is shown as that. And in this particular case, it's still a steel stud wall, so we do have our steel channel right there, and then the wood is basically used as a nailer for the window attachment. This gets me to structural plans. And again, there's a lot of subdisciplines that have individual ways to represent things, electrical plans, for example. And we can't cover everything here, but we're going to look at structural plans just really quickly. So structural plans typically represent a beam, not as a beam, or not as the width of the beam, but rather as a thick line. So beam is represented as a thick line right there. Part of this representation, and what you're looking at on the left here, is a plan view. Part of this representation is that you leave gaps where beams frame into other beams. So let me show you how this looks like. This would be a continuous beam. This would be a beam that frames into the continuous beam, and there's another beam framing in from the other side. And you always leave this little gap, because otherwise you don't know what frames into what. And you'll see that on the left here, where you see one beam ending and the other one framing into it, and so on and so forth. But you also see that this one here is a continuous beam that continues over the second column grid on the left here. So that's an important part. Beams are then called out on their side, and that can either be the dimension of the beam. On the bottom here, there's a steel detail. So right here, this is typical steel detail where you have a similar symbology, but then you'll call it out with the actual dimension on the detail. On the top here, what we're doing is we're basically referencing this particular beam. This is beam B11, and there would be a table to its side, and you'll find the sizes in the table. Same here, there's my B7 beam, and so on and so forth. Columns are represented like this if it's a heavy timber building, or like that if it's a steel building. And those don't necessarily have to be the exact dimension. They could be some symbols rather than anything. And then at the ends of these beams, you may have noticed, some symbols there, and they represent the connections. So there's different connection types, different ways you can connect a beam, whether it's a moment connection or shear connection or something like this. And that can be represented in plans like you see here, and then of course you'll find a detail that corresponds to that explains how this particular beam looks like. There's other things often called out on structural plans too that make sense, things like camber or shear connectors, if this is a steel member, for example, and that's usually added and explained in the structural plan, and then added in the overall framing plan. Now, that's the primary structural system, so those are the beams that hold up the structure, but then between those is a floor system. In our case, it's cross-laminated timber. This could be a steel deck, could be all kinds of different things. And then you need to show the span direction for that floor system. And in this case here, the span direction is north-south, so basically up-down in this plan. And it's indicated with a squiggly arrow that you can see right here. And then of course, if this is a one-way system, as what we have here, it looks like that. If it's a two-way system, then of course you'd have something like this here, which we don't have. So I'll take it back out. But that secondary symbol shows you the floor span. And then there may be another plan set that calls out exactly, plate locations and so on and so forth. But overall, the span is important to understand at this point, of course. Okay. So that's the overall structural plan setup, and the beam locations and so on. And similar to the architectural plans, there's going to be a set of details, and very likely a large set of details. And in this case here, I'm just pulling out some steel and concrete details because they have particular terminology. So for a steel detail, as you can see up here, you would represent the members, whether it's an HSS or a white flange member, and you'd call out gusset plates and all of those things. And then for steel, what's important is that you need to specify welds. There's a whole language that goes along with that. It's a little explained here, but basically what we have here is this little triangle that is a fillet weld. And a fillet weld basically creates this triangular weld between two pieces. Now you'll see on the right explained what we're talking about here. The arrow points at the weld location. You have to make clear which side you're welding from, so then sometimes you need these kind of squiggly arrows. Then on the bottom of the horizontal line you see what weld you need to do at this particular side, fillet weld, and on the top of the line you see what the opposite side looks like, and it's also fillet weld. So in other words, there's a stiffener plate here that's welded with fillet welds on both sides. Down here you see a weld that's only on one side, and that's supposed to be field installed as opposed to shop installed. So there's quite a bit of detail there, and you'll be well advised to look up all of the various weld symbols to understand this. For concrete, rebar is the magic juice, and so then of course we need to understand what goes in where. And typically you'll see what you see there on the bottom right, which is a typical column detail where then the arrangement of the rebar is called out, and maybe the ties are called out. But then for the specific individual column, you may find that in a schedule, as you can see here. So this particular column with that size uses that rebar. And then of course you know exactly that you need 12 number 8 rebars as your vertical reinforcement and a bunch of ties that are number 4s, etc., etc. So again, this is a very deep topic, but this way you understand the basics of it all, and you can understand the structural component there too. Okay, so like I said, this was really just a basic introduction to plan reading. There's lots more references. You'll see much more of what there is in your materials and methods class, of course. As references, I put these 3 here. So the Architecture Graphics Standards, the student edition, is a really good volume for understanding these particular details, but also materials and methods and how things fit together. So that is very helpful for reading plans and for drawing plans. Second one, Architectural Graphics, is more geared towards drawing plans, but it also covers a ton of plan reading. The third one is just a general pocket reference for blueprint reading, and there's a lot of books out there on blueprint reading, but most of them also cover materials and methods. So if you're looking for something that goes along a materials and methods course or book, then you may want to find something that's a little bit more concise and condensed. Okay, so this was a bit of an intro to plan reading, and I hope you're prepped now for looking through large plan sets, and at the very least finding out what you're looking at and what you're looking for.